Hi there, my name is Andrew Brown, and welcome to Carbohydrate Classification. This video is going to introduce a couple of basic categories into which we commonly organize carbohydrates, how to name the monosaccharides you are likely to encounter on the MCAT, including the L and D prefixes associated with some enantiomeric sugars, and then we'll get some practice differentiating between the classes of isomers used to describe sugars. After completing this review, the goal is to be able to identify and classify any carbohydrate that the MCAT might throw at you. You'll want to be able to answer questions such as this one, which pose two carbohydrate molecules seemingly similar and ask you to parse the differences between the two molecules. Now we're going to review all those concepts associated with monosaccharides in a bit, but keep this question in your head as we move forward. In terms of the basic categories into which sugars will fall on the MCAT, the two with which we are really concerned are monosaccharides and polysaccharides. First, a monosaccharide is a simple sugar that can't be hydrolyzed into simpler components. The example for you here is glucose. Now, when we talk about complex carbohydrates, or these polysaccharides, what you really should notice first of all is that something like cellulose here is essentially just a combination of multiple glucose molecules strung together in a chain. Once you are comfortable differentiating between simple and complex carbohydrates, the next step is to be able to identify and compare individual monosaccharides. Depicted for you here is a molecule of D-glucose. At this time, we're going to see how to name generic classes of monosaccharides. The first step is that suffix, OSE or OS. All sugars and carbohydrates are going to have it. The next step is to count the number of carbons in the molecule. So in the example of D-glucose here, counting vertically, we see 6 carbons. Don't forget to count the aldehyde carbon, number 1 there. And so the prefix associated with 6 is hex, meaning we have a hexose so far. And then the final step is to add the prefix for that correct functional group. In this case, as we said before, it was an aldehyde, which makes the name of our 6-carbon sugar here an aldohexose. These are just a few common carbohydrates. When you take the MCAT, you'll be expected to know these 4 at a glance, so familiarize yourself with them right now before moving forward. Now it's time to take a look at the L and D configurations. We use these initials to compare enantiomeric sugars, sugars that have a mirror image molecule. And as you can see in the example of glyceraldehyde below, the orientation of the functional groups about the central carbon is what determines that L and D configuration. Now that you have been introduced to enantiomers and the nomenclature system associated with them, we can explore other types of isomers. First are diastereomers, which differ at least one stereocenter, but are not mirror images. Take D-glucose and D-talose, for example. These are diastereomers that differ at 2 stereocenters. We call them the C2 and C4 positions. To wrap up our survey of isomers, we should now define epimers, which is the special class of diastereomers that differ at only one stereocenter. In the example of D-ribose and D-arabinose pictured below, you'll notice that each stereocenter along the carbon chain is exactly the same, except for one, the second carbon. This owes to the naming convention which we apply to epimers. Because these two sugars differ at only the second stereocenter, we're going to term them C2 epimers. That concludes this video's material discussion. Now I want you to put what you've learned into practice with some sample questions. Your first question is asking you to identify and categorize the following monosaccharide. Now you've also been given the common name, D-fructose. However, we're going to need to use those steps reviewed earlier with nomenclature conventions in order to get the family name. The correct answer is ketohexose. Now if we apply those nomenclature conventions reviewed earlier, we see that this is a 6-carbon sugar, and also that the functional group is a ketone in this case. Now we want to do exactly what we did previously. We take that ketone functional group use the simplified version of it, keto, and we simply apply that to the beginning of the sugar name that we are building, and it becomes ketohexose. Now why don't you tackle a second question? This one is asking you to imagine D-glucosamine, a monosaccharide structurally similar to D-glucose, except for the replacement of the 2C hydroxyl group with an amine group. Also, please keep in mind that the question stem is asking you to determine which of the following statements is false, a common MCAT tactic for which you should be on the lookout. The answer here is C. D-glucosamine is a pentose. Because the question stem told us that D-glucosamine is structurally similar to D-glucose, we can assume that they have the same number of carbons. Therefore, the easiest answer choice to pick out as being incorrect is the one that states that glucosamine is a 5-carbon sugar, which is what pentose means. And now for a third question. This one is asking you to compare D-mannose with an unknown sugar, carbohydrate A. The answer here is L enantiomer. So notice if we draw a plane of symmetry between the two molecules, they appear to be exact mirror images of one another. Each stereocenter along the central carbon chain is reversed in carbohydrate A when compared with D-mannose. This is, of course, with the exception of the aldehyde group at the top. Because these are freely rotating, we don't really care about how they're depicted in this orientation. Because there are differences at every single stereocenter rather than just one, we can eliminate epimer as a possible answer choice, and we can also eliminate constitutional and conformational isomers, which refer to differences in connectivity or spatial arrangement of the molecule. One of the finer points about this question, because carbohydrate A is the enantiomer of D-mannose, it therefore must be classified as an L enantiomer. Any enantiomer of a D molecule is going to be L, and vice versa. That was our final question. If you aced it, congratulations. If not, feel free to go back and watch this video as many times as you need. Before we finish, let's review what was covered in this video. We started with glucose, a monosaccharide, and saw that polysaccharides, such as cellulose, are really just chains of one or several monosaccharides. We then acquainted ourselves with the D and L nomenclature system and practiced differentiating between enantiomers and diastereomers. Thank you very much for your attention and for watching. I'm Andrew Brown, and good luck on your continued journey toward MCAT success.